Okay, once we have the chart, we do our chart. So again, like we list and start with a couple equations. Here we're going to start with a couple equations. C squared is equal to A squared plus B squared. How is that different from ellipses? Yeah, in ellipses it is minus. Here we've got plus. Eccentricity, C over A. How is that different from ellipses? It's not, it's the same. Yeah. When you look at ellipses, which is bigger, C or A? C is bigger than A. Which means what is this going to end up being for hyperbolas?
What is that dotted orange line there for?
Dotted orange line? Oh, it's a vertical line at the vertex. So B is the distance from the vertex to the asymptotes, on direct vertically.
Oh. So that vertical, that dotted line is 2D?
Yes.
Or not?
So when you talk about eccentricity of a hyperbola, what would happen if that eccentricity was 1? Yeah, you'd have 2 lines, right?
A and C would have to be the same.
If eccentricity is 1, C and A would be the same, and you would end up with just 2 lines.
Or 2 lines.
You'd end up with just these. If the distance to the focus is the same as the distance to the vertex, we're going to get that. Basically, as this moves closer and closer this way, this line gets closer and closer here, and when they meet the same point, where A and C are the same, you get just the 2 lines there. Don't worry too much about it. But notice, as this gets more and more eccentric, what happens? Well,
all the way.
I just mean, what happens to this number, the eccentricity, as it gets more eccentric? What number does it go to?
0.
No. No, remember, 1 we said is that if it gets completely non-eccentric.
Oh.
So it's going to get bigger and bigger. So remember, when you talked about ellipses, what had no eccentricity? If eccentricity equals 1, you had a perfect circle, right? And as it got closer and closer to 0, it got more and more flat out. And hyperbolas, as you get more and more higher eccentricity, you start getting something more and more like this. As C gets bigger and bigger compared to A. So again, it gets flatter, but it gets flatter in the opposite direction. Yeah. And the idea, though, is these things get closer and closer together, right? That's what he was going at. Okay, again, we're going to do horizontal and vertical. So first thing, the equation. So watch the equation, see if you can identify what's different between this and your ellipses. So what's different? Yes, it's a big square. Yeah, minus instead of plus. Now, if you look in your book, I believe in these 2 books. Yeah, there is a typo on page 443. Yes, you can write it in. When it's doing this equation, it does not put in the minus. What the book shows is this. It's a typo.
Where? Oh, that's weird.
Yeah. So if it's vertical, What changed from one to the other? Okay, so the x and y part switch places. How is this different from how the ellipse behaves?
So bottom, the B and A.
B and A switch.
Is there a difference though?
What do you mean?
Like if that would be different, I mean.
Well, it's significantly different because of which one is now negative. If we multiply this out, we have a negative x squared. This would be a positive y squared. Here we have a positive x squared and a negative y squared. Now, one different thing with this one is A is not necessarily bigger than B. A doesn't have to be bigger than B, whereas with the ellipses we said A did have to be bigger than B.
But that's why A and B are switched.
Yeah.
The
Yes. The A and B does not tell us the orientation. Instead, it's which one is negative. So if I wrote this, they're negative x minus 3 squared over 4 plus y minus 3 squared over 18 equals 1. Is this vertical or horizontal? How can you tell? Yeah. We look at what part's negative to determine which orientation we're going to look at. So here, if it's in this standard form, it's very clear which one's negative. Everybody with me? Yeah.
So like in ellipses, the order like the y-axis matters.
Yeah. I mean, it just depends on what A and B were. If they're both positive, what would happen if they're both positive? Yeah, it's ellipse. If they're both negative, that's it. Except for then we have a negative one over here and we get something interesting. The graph. So first these do have asymptotes. It's going to look something like that. And vertical. No, we could have a really wide one like this and still have it be there. So basically, this is just the vertical horizontal tells us what direction it's opening. They're not parabolas. That's actually a plan I was going to bring up. These are not parabolas. How wide can parabolas go? Okay? And if you went to infinity, they are still curving, very gently. Hyperbolas, they still curve, but they are approaching a line. So if you looked at a hyperbola really zoomed out, it's going to look like this. Look at a parabola, so if you had a positive and negative parabola zoomed out, they're going to look like this. Or they might get narrower and narrower, but they're still going to be doing that. Hyperbolas, they are, in the long run, they're approaching this line. That's why we call it the asymptotes.
Do parabolas have asymptotes?
No, parabolas do not have asymptotes, because they are not approaching a line ever. Let's see, after graph, next one we have is center, easy one.
Are verticals always wider?
No, I just drew wide to say that we can still have this, even if it's narrow here, it can still be a vertical parabola, or hyperbola. Where's the center going to be? Hope everybody's starting to see a pattern here. So finding the center or the vertex should be the easiest one. If you get it in standard form, it should take you less than 5 seconds to get the center. And vertices, what do you expect them to be? So, yeah, h plus or minus a. And y part, okay, over here. So remember, a is still the distance here from your center to your b. It does not actually come into play with these, any of them. So we're talking about foci. What do you think it is?
H plus 4 minus B.
Yes, good. And the y?
Okay.
So h comma k plus or minus c.
That was B for the asymptote.
So b will come into play when we talk about the asymptote. So that's one of the things we're going to add to this list that is not on any of the previous lists, is asymptote. So, notice, when you look at the asymptote, how would you expect to write the equation for it?
Like, yeah, right.
Y equals mx plus b. Okay. You're going to get statement. Okay. So, we are going to do y equals mx plus b, just like if we're doing line. So these are not horizontal or vertical asymptotes. They are slant asymptotes. If we went from our center, let's say if we were at 0, 0, what would the slope be? For this one? B over A. Remember, rise over run? So rise was B, run of A. Now, how do we move a line around? So let's say we have y equals mx plus b. How would we move it to the right? In general, how do we move things to the right? Okay, we're using h. What could we do with h to move this to the right? So let's consider this. Y equals ax squared. What would I do if I was moving this to the right? Yeah, we'd say y equals a x minus h squared. We replace x with x minus h. If we apply the same thing up here, what would we do? Okay, m x minus h plus b. Does that make sense? Okay. How would we move it up or down? So let's actually move this b over here to make it into the form y minus k equals m x minus h. Does this look more like what we've been doing? Okay, everybody, you can see this is a bit more like what we've been doing. But this is just the same as if we move this b over here. So now, in this form, what did we say the slope of the asymptote was? Well, in this case it was b over a. What about for the other one? Because we've got two asymptotes. So the bottom one, what would it be? Negative b over a. Good. So we get our asymptote. For this one, y minus k equals plus or minus b over a x minus h. So did you see how we built this up?
Friday.
No.
Okay. Oh, I mean Monday. Let's do it Monday.
I would like it by Tuesday. Because as I know where this is going to be a bit harder.
Yeah.
And we're going to talk more about this lesson tomorrow. We're not going to have time for everything. So, if we're dealing with the other asymptote, what do you think the slope is going to be? Yeah, it's going to be, so it's going to be y minus k equals the plus or minus a over b, x minus h.
What? Because A is down height.
Yeah. So everybody with me on these? Okay. So this is a bit more complex, I think, than the others. So, how about graphing these? That sounds like a great plan. We need to graph them. Let's see. X minus 1 squared over 4 minus y plus 1 squared over 9 equals 1. What do you think we should do first?
Well, first,
And how about first find the center?
center, yeah.
And then when we're drafting these, the first thing we have to find is the center. So where's it going to be at? 1, -1. So there's my center. Next thing I would do, find asymptotes like Adam was saying. So yeah, what is A, what is B? 2 over 3. That's my slope, plus or minus. And no, we can actually just go straight over the center because our center has it. So 1, 2, 1, 2, 3, and 1, 2, 1, 2, 3. And typically you put asymptotes in as dashed lines like you did before. So it could be one of them. What do you mean? Like the left side?
Oh, that's a different one.
Okay, next thing,
Wait, how did you figure out that?
okay, we did, remember, A over B for the slope?
Uh-huh.
So we did A was 2, B was 3,
Oh, yeah.
and went 1, 2, slope over 3.
Oh.
And remember, because we moved it to where the center was.
Mm-hmm.
Okay, next thing you said was vertices. How far are your vertices away from this point? 2 units. How do you know? Because what? Yeah, because A is 2. B over A.
Did A over B for one and B over A for the other? You did the same for both.
Let's see, we're doing a horizontal one. We should have been doing B over A, not A over B. So 3 over 2.
Oh, yeah.
So 1, -1, so 1, 2, 3, 1, 2. My mistake. Oh well. We can fix it. Well, I don't know about your paper, but I can easily erase it. If you're doing it in pen, it's very hard to fix something like that. Okay. So then we said the center was how far away, or the vertex was how far away from the center? A units. What is A? 2. So this is horizontal. So 1, 2. So these 2 are my vertices. 1, 2. Now what? Do an approximate.
Like that.
Well, is your focus part of the graph? No, you don't.
So we just have to graph like that and then.
Yeah. So, these are actually really, I did very well on this. I did very good.
Good job.
Thank you.
Power visual.
Yes, I'm very proud of myself. Usually it's very hard to get these curves to go.
There's a point right there.
Here's a problem I see. Don't do it this way. Okay, if you do it that way, you're not approaching the asymptote. That is a common mistake I see people do when they're doing hyperbolas. If you pull it away from there, you've got a problem. Because then you're probably graphing a parabola, not a hyperbola. And you do need to find your vertex. If you don't find your vertex, you don't know how far left to go. But graphing these is really not all that challenging. So you have to get several parts. Now, of course, there's also going to be questions like figure out or identify the characteristics. So given the equation, given this equation, can you get A, B, C, H, K? The question?
Are we going to be able to?
On what? Why would you get to use notes when you use notes?
How are you going to do that?
What?
So we have to memorize it?
Well, what I said is you get a formula sheet that I'm going to make for you.
What will it be?
What will it contain?
It will be basically all of, most of this stuff with no labels at all.
But will
And for all of them, for all the different. This part is what it would show, no graph either.
But it would show it all put together, so we just have to know like
This formula is a hyperbola.
Yeah. So I would give like all of this part for both sides, but I would also give all the ones for the parabola, all the ones for the circle. all the-
Yeah, you have to know.
Recognize.
Well, I'll give you a sec. Are you
What?
gonna organize it by like parabola, like parabola, this, or
Yeah.
like horizontal for everything, or vertical for everything?
Like I'm gonna put all, I don't remember, I'll put all the stuff in one, all the stuff together.
What do you say for